I want to go through and just do some basic powers of I. So we know I to the first, anything to the first is itself. So it's really I, and just a friendly reminder that I is the same thing as root negative 1. We also learned that I squared is negative 1 because if you square both sides of this equation, you get I squared equals negative 1. So if I asked you to compute I cubed, you could think of it, as long as you know your exponent rules, as I squared times I to the first. When we multiply like bases, we actually add the exponent. So you can always take an exponent and break it into multiplication problems so that all the exponents add up to the starting one. And if we change I squared to negative 1, what we're really doing is negative 1 times I, and of course that's going to be negative I. And I'm going to do kind of the same thing for I to the fourth. That would be the same thing as I squared times I squared, which would really be negative 1 times negative 1, and that of course is going to be positive 1. So we'll keep that pattern going with I to the fifth. I happen to know that I to the fifth, it can be represented so many ways, but I know I could write it as I to the fourth times I to the first. But we just found out that I to the fourth was positive 1. And I to the first is just I, so 1 times I is I. So there's lots of ways to break up I to the sixth. I'm a fan of I to the fourth, so if I can get a 4 involved, I do. 4 plus 2 is 6, so this is the same thing as that. But I to the fourth is 1, and I squared is negative 1, so really what's going to happen is we get negative 1. Again, for number 7, I'm going to break it into I to the fourth times I to the third. So I'm changing 7 into 4 plus 3. We know I to the fourth is 1. And we have up here that I cubed was negative I. So I'm going to borrow that. And then if I multiply those together, I'm going to get negative I. Last but not least, I to the 8th can be rewritten as 4 plus 4. So I to the 4th times I to the 4th, which we know are both 1. Another way to write this is you could just write I to the 4th quantity squared. So if you have a problem like this, you can just multiply the exponents, and 2 times 4 is 8. If it's expanded, you add the exponents, and that still gets you 8. And since I to the fourth is 1, really what I'm doing is 1 times 1, which of course is 1. So the idea is I want you to observe a pattern that's going on here. We got I, negative 1, negative I, 1. I, negative 1, negative I, 1. If you notice, these items, these answers match. And that's going to happen every 4 times. You're going to cycle through the same number every 4 times. So you're going to cycle with I, negative 1, negative I, 1, and then that just repeats. So a good rule of thumb is every increment of 4, it's kind of like you can ignore it because anything times 1 is itself. So if you ever get I to the fourth, you can kind of just ignore that from the problem because it's 1. It's not going to change the final answer. So what we'll do is I'll teach you a little concept then, and then we'll come back to these higher powers of I, and then we'll see if we can put that to good use. If you recall, it's not good to have a square root in the denominator. And I is the same thing as root negative 1. So if you have an I in the denominator, you actually do have a root in the denominator, and that's going to need corrected. We're going to correct it the same way as a normal problem with a radical. We're just going to multiply it to itself. So we're going to take the top and the bottom times I, and we'll get 5i over I squared. Then we're going to change I squared to negative 1, and then we can simplify that to be negative 5i. Same idea with 2. The 8 and the 5 are fine. There's nothing wrong with that presentation. It's the I that's the issue, so that's the I that we're going to correct. And we're going to use the same process as before. So up top we'll get 8i, and on the bottom we'll get 5i squared. Again, we're going to change I squared to negative 1, and then we can multiply negative 1 times 5 and get negative 5. So my answer would be 8i over negative 5. You could make it negative 8/5 I, however you want. You have to have a negative in the answer. So those really aren't too bad. It's problems like number 3 that sometimes trip us up. So a lot of kids will take this approach. They'll think, well, this worked for number 1, this worked for number 2, let's do the same thing for number 3. But here's what happens. You would technically have to put the bottom in parentheses because there's a plus, so it will require distribution. And if we distribute I into the parentheses, we're going to get 2I plus I squared. So we still have an I down here. There's nothing I can do with 2I. So that's an issue. So we don't want to handle it that way. We're not going to get anywhere. So a simple rule that we're going to use, and we've used this rule before, is if we have a sum or a difference that involves a radical, or in this case an I, in the denominator, we're going to multiply top and bottom by the conjugate. So we're going to actually use conjugates to help us out of this jam, just like we would with normal square root problems. So rather, we want to multiply by either 2 minus I or negative 2 plus I. Just remember, a conjugate means we're going to change one of these signs, not both. So we'll do some basic math here on the top and get 8 minus 4I. And if you FOIL the bottom, if you remember, we're going to be left with whatever the first terms are and the last terms, because the middle ones will cancel out. So we'll get 4 minus I squared, and then we'll clean that up a little bit because we know I squared is negative 1. And if we do 4 minus negative 1, of course we get 5. So my answer would be 8 minus 4I over 5. And I just solved this. Apologies. That should be a minus. Somehow I must have typed a plus when I made this answer key. That should be a minus. Apologies. So in our next video, we're going to do some mixed review problems. And I'm actually going to start with these higher powers of I to show you some easy tricks to deal with it.